Alright, so to find f of g of x, we have to plug into x wherever we see an x in f of x, right? So what does that equal? Yeah. Alright, so remember, when everything is being multiplied on the inside, we're allowed to distribute the squared, the exponent. So that is 2 squared, which is 4, and then x squared is x squared. So f of g of x is 4x squared minus 6x. Any questions on that? Alright, what about g of f of x? How do we find that? Yep. So we just take f and plug it in wherever we see an x and g. And for this one, we can just distribute the 2. Good. Alright. Now what about g of f of g of x? Alright, how do you think we should approach this one? Sure. So what is f of g of x? Okay. So there's definitely more than one way to do this, and I actually think Tristan's way is easier than what I was going to say. Kind of caught me off guard. But yeah, so we can find what f of g of x is first. And now all this is saying is we take 4x squared minus 6x and plug it in for x and g. Any questions on that? I'm not even going to show you my way. I like this way better. What was the other way? What'd you do? Yeah. So you did, of course you did what I did because that's how I showed you. But yeah, so what I was gonna do was start with the outside and then move in. So the outside was to X, leave a space wherever you see an X, and then move into the next one, which is F. Wherever you see an X, you leave a space. And the next thing is G. In those spaces, you're going to put G. So if you simplify this, you'll get the same thing as this, but this way is definitely easier. But if you know this way and you're good with it, by all means, you can stick with that. Any questions? All right, how do we find odd and even functions? You said one of the x's? Oh. So we need to see if, how do you know it's even? Yeah, we know it's even if f of negative x is equal to f of x. And how do we know it's odd? When f of negative x is equal to what? Almost. Yeah. So it's even if f of negative x is equal to f of x, and it's odd if f of negative x is equal to negative f of x. And it's neither if neither one works. So let's see if this one is odd, even, or neither. What is f of negative x for this one? All right, what is negative x squared? It just becomes positive, right? And positive 3 times negative x is negative 3x. All right, so this is not equal to that, right? Right. So because they're not equal, that means it's not even. So next thing is to factor out a negative out of here to see if it's equal to this with a negative on the outside. So if we factor out a negative, we get negative x squared plus 3x. Is the inside equal to that? No, so then it's not odd. So this one is neither. Any questions? So plug in the negatives and simplify. first thing to check is if it's the same as the original. If it is, then it's even. If it's not, then we check to see if it's odd. To check to see if it's odd, we have to factor out a negative. If whatever is left on the inside is the same as the original, then it's odd. If it's not, then it's neither. Make sense? All right, what is f of negative x for this one? We get negative 3x. What's negative x cubed? Yeah, so negative x cubed just stays negative, so these two negatives cancel out and it becomes positive. All right, is it the same as the original? No, so it's not even. Now let's factor out a negative. If we factor out a negative, what's left? Is that the same as the original? So this one is odd. What is negative x to the fourth? Yeah, because the exponent is even, it becomes positive. And this one doesn't change because there is no x with it. All right, is this the same as the original? Yes, so this one is even. Any questions on how this works? For number 2? So when you factor out a negative, the 3 becomes positive and the x cubed becomes negative. So they flip signs. All right. Any other questions on this one? All right, last thing is transformations. So can you tell me how this one was transformed from x cubed? Yeah, the negative over here tells us that it was reflected. What else? Yeah. This 3, because it's greater than 1, that means it's a stretch. Okay. Because this is a -1, that means this is a +1, so that's to the right. Anything else? Any questions on number 1? All right, what about number 2? How did this function change from square root of x? Yep. Because this is plus, that means we had a -7. So left 7. What else? This -3 tells us that it went down 3. All right, number 3, how did this one change from 1 over x? What else? Yep. What else? How do we know it's compressed? That's not a fraction less than 1. Good guess, though. So we have a 2. If this was like a 0.5, then that'd be a compression. But since it's 2 and that's greater than 1, it's going to be a stretch. Or if we had one that looked like so in this case, A would be 1/2, and in this case, A was 2. So this one would be compressed. This one is stretched. Make sense? All right. Any questions on transformations before we move on, or any of the other topics? All right, as always, I'll scan these and upload it with our notes. Sure. So an asymptote is a line on the graph where the function doesn't exist. DNE just means doesn't exist. So you'll see that the graph gets very close to it but never really touches it. Do you remember the three types of asymptotes? Yeah. We have slant asymptote, slant or oblique. We have vertical and horizontal. All right. So the transform function can be used to tell us what type of asymptote we have. So for example, if we have y equal to 1 over x, the transform function is going to be y equal to a over x minus h plus k, right? The vertical asymptote, do you know what the equation is? Is it x equals or y equals? If it goes vertically, which axis is it going to cross? Yeah, so our vertical asymptote equation starts with x equals. What about horizontal? So when you're given a transform function, your vertical asymptote is going to be equal to h. So if we solve this, set it equal to 0 and solve, we get x is equal to h. Why do we have to set it equal to solve it? Set it equal to 0 to solve it. Why do we need to set this denominator equal to 0? Any guesses? It is because the function does not exist when it's 0, remember? So a fraction doesn't exist if the denominator is 0. And asymptotes are lines on the graph where the function doesn't exist, right? So if we set this equal to 0 and solve for x, solve for x, we get x is equal to h. So whatever h is, that is what our asymptote is, because that's where it's not defined. And because there's no way for this to be 0 based off of, because we can't get a 0 in the denominator, the horizontal asymptote is going to be determined by the k value. So if a does not equal 0, is there any way for this whole fraction to be 0? Yes, no. The question was, if a is not equal to 0, is there any way we can make the whole fraction 0? If a does not equal 0, is there any other way to make the fraction 0? No. Yeah, the answer is no. So if a does not equal 0 and the denominator cannot equal 0, then there's no way for this whole fraction to be 0. So that means there's no way for y to equal k. That is why we have a horizontal asymptote at y equal to k. Does that make sense? Because we cannot get this fraction to be 0 when a is not equal to 0. There is no way for us to have y equal to k, because this cannot be 0. All right, so examples. All right, so that is for when you have rational equations. What about when you have any other type of equation? Like, let's say we have a polynomial. HA is horizontal asymptote. There are 3 different possible solutions you can have for horizontal asymptote, and it is based off of the degree. Do you remember what a degree is? Degree of a polynomial? Yeah, so it's the highest exponent on an x, basically. So the highest exponent on a variable determines what the degree of a function is. So if the degree in a numerator is greater than the degree in the denominator, for example, if we had Do you know what the horizontal asymptote is? Did you guys talk about this in trig at all? Do you remember what it is then? Neither. So if the degree in the numerator is higher than the degree in the denominator, then there is none. What's so special about where we have the degree in the numerator exactly 1 degree higher than the denominator? Do you remember that? No, that's not what I was asking. So Corey, you told us about the slant asymptote. Do you remember how to find that? All right, that's cool. All right, so we have a slant asymptote. Actually, never mind. We'll come back to that later. So if the degree of the denominator is greater than the numerator, for example, we have y equal to x minus 1 divided by x squared plus 1. Do you know what the horizontal asymptote is? When the numerator is a higher degree than the denominator, we have no horizontal asymptote. But what about when the denominator is greater degree than the numerator? Do you remember? Yes. It's always going to be y equal to 0. And the third case is when the degrees are the same. So if the degrees of the numerator and the denominator are the same, how do we find the horizontal asymptote? Do you remember? The horizontal asymptote is going to be the ratio of the leading coefficients. Do you remember what the leading coefficient is? If not, the leading coefficient is the number that is with the variable with the highest exponent. It's not always going to be the first thing we write, but it's going to be the number with the variable with the highest exponent. Any questions so far? So there are conditions for when we can have a slant asymptote. We have a slant asymptote first when there is no horizontal asymptote. And most importantly, the degree in the numerator is exactly 1 degree higher than the denominator. Do you remember that? Yeah. So there has to be no horizontal asymptote, and most importantly, the degree in the numerator has to be exactly 1 degree higher than the denominator. You said you kind of remember it. Do you remember how to find the oblique asymptote? To find the slant asymptote, we have to use long division. Now, I know you remember that. Right? All right. So, is there a horizontal asymptote for this one? Why? There's no horizontal asymptote because the degree in the numerator is higher than the denominator. What about vertical asymptote? How'd you find that? Exactly. Is it y equals or x equals? For vertical asymptote. Yep. So horizontal asymptote, we look at the degrees. We have none because the degree in the numerator is higher than the denominator. For vertical asymptote, we look at the denominator. We set it equal to 0 and solve for x. Do we have a slant asymptote? Why do you say that? Yeah, there is no horizontal asymptote, and the degree is exactly 1 degree higher in the numerator. So we do have a slant asymptote. It's going to be a y equals. To find what that is, we have to use long division. Do you remember how to do long division? Yeah? No? So when we're dividing, remember, we're trying to figure out what to multiply to x to get x squared. What do we have to multiply to x to get x squared? So once we figure out what we have to multiply to x to get x squared, we actually multiply to both the x and the -1. And when we come down here, we do what? What sign? We subtract, so we put the opposite sign. So x times x is x squared. So down here we write -x squared. X times -1 is -x, so down here we put positive x. The first thing should always cancel out. There's nothing to combine the x's with, so just bring it down. And nothing to combine with the 2, so bring that down. All right. What do we have to multiply to x to get x? Positive, right? So if we multiply x minus 1 by 1 and we put the opposite sign here, we get -x plus 1. Is there anything to multiply to x to get -1? That's not a fraction. No, so then our answer is x plus 1. That is our oblique asymptote. Do you guys remember this? Because we had to multiply x by +1 to get positive x. That's a good question. So our answer is whatever's up here. Intrig. Oh boy. Huh? Okay. Alright, so it's new to most of you guys? Oh boy. Alright, a quick little run through of long division. Say we have y equal to x cubed plus 4x squared minus 7x plus 1. And we're dividing that by x squared minus 7. So we're dividing this polynomial by this polynomial. So to set it up, we have x squared minus 7. And our dividend is the numerator. So for long division, we're trying to figure out what to multiply to this x value in order to get this one. All right. So what do we have to multiply? Let's make it just x so it goes longer. What do we have to multiply to x to get x cubed? So we have 1x and we need 3. So what do we have to multiply to that 1x? Huh? Can't hear you. Is it 3x? So 3x times x is 3x squared. So it would be x squared. So you will have to multiply x to itself twice to get x cubed. So this is x times x times x, right? Does that make sense? Okay. So once we get x squared, we take that and multiply to both of these. So what's x squared times x? X cubed. And we take the opposite of that. What's x squared times negative 7? We're multiplying. So negative 7 times x squared. Yeah, that would be negative 7x squared. So what do we write down here? Yeah. All right, now we do some math. X cubed minus x cubed, they cancel each other out. And what is 4x squared plus 7x squared? So when we're adding, remember, when they have like terms, we add the coefficients. So that becomes 11x squared. And we bring down everything else. And then we start over. What do we have to multiply to x to get 11x squared? Just 11. we still following? Okay. So to get 11x squared, we have to multiply x by 11x. So now we take this and multiply to both of these and write the opposite signs down here. So what's 11x times x? And what do we write down here? All right, what about 11x times negative 7? And what do we write down here? Yes. All right, again, 11x squared, negative 11x squared, they cancel each other out. We have 7, negative 7 plus 77, or 77 minus 7. We get 70x, and then we bring down that plus 1. What do we have to multiply to x to get 70x? Yeah, 70. Now we take 70 and multiply it to both x and negative 7 and write the opposite down here. So 70 times x is 70 times x is 70x, and we write negative down here. What's 70 times negative 7? Negative 490, so we put positive 490. Is there anything we can multiply to x to get 491? No, so that means 491 is a remainder. And we write our remainders like that. So y equals x squared plus 11x plus 70 plus 491 divided by x minus 7.